Well, we continue with physics, kinematics and forces, and we'll see today the variation of the state of motion. For example, looking at this car, we can see that the velocity increases. That means there is an acceleration. The engine is producing a force on this car. When a force F is applied to a body of mass m, this acquires an acceleration, a, and the following expression is fulfilled. Force equals to mass times acceleration. So this acceleration is produced by the force. What happens when there is no force? Then there is no acceleration, and the velocity is constant. Finally, when the velocity decreases, also there is an acceleration, this negative acceleration, a deceleration if you want. And also there is a force that is stopping the car. The force against the motion decelerates and velocity decreases. Friction. Well, this is another type of force that we can find in everyday life. There are two ways of finding this in fluids and with solids. Fluids means liquids and gases. This is what happens when a body moves in a fluid like air or water. It is due to the position of the fluid particles to separating. For example, this car is moving through the air and there is an opposition of the particles of these, the molecules of the air. Solid friction, this is what happens when two solid bodies come into contact. For example, here, this is a box and this is the floor, and you can see here where this surface, the interface between the two surfaces, where the friction is produced. This is what happens when two solid bodies come into contact. That is the reason it is difficult to drag objects. And we can see some examples in everyday life. For example, pushing furniture is most difficult on rough surfaces. Rough means something like this, okay? And flat, smooth is like that. Rough surfaces have some curves. Tires must grip the road in curves so that they do not slip. But what happens in snow? Working or driving a car on water or ice is very difficult. In these two first pictures, there is friction. Here there is no friction, almost no friction. And also here, in this train, magnetic levitation trains can travel at high speed because there is no friction at all, always very, very low, only the air friction. So friction is a force that opposes motion. The force of gravity is another type of force that we can see in everyday life. For example, in our planet, the Earth, attracts other bodies that are in its radius of action. But this attraction is not limited to our planet. So gravity is a force that acts at a distance between two bodies that have mass. So mass is important. It increases with the value of these masses and decreases with the distance that separates these bodies. So, for example, this plane, the force of gravity increases with the mass of the bodies and decreases with the distance. There is no need for contact between the bodies that is acting at a distance, and it always goes toward the center of the bodies. These arrows are indicating the force of gravity. It's toward the center of the planet in this case. And what is weight? Weight is another force and can be calculated multiplying the mass of a body times the gravity, the acceleration of gravity. This acceleration of gravity depends on the planet. For example, in our planet, the Earth is about 9.8 meters square second, nearby the surface. For example, this eagle has a weight force that can be seen using this vector pointing towards the Earth. What are the effects of forces? If you remember the word deformation and the change of the state of motion, well, also with weight, that is a force, we can see this phenomena. For example, here, deforming this body because of the weight of this block. And also, the sun and the moon are changing the shape of the fluid, in this case the oceans, on Earth. Okay, that is a deformation. Changing the state of motion is, for example, when you launch a body and then is going backwards, is going down again. So that is because of the weight force and also the force of gravity. Basically, the weight force is the force of gravity on a body. Well, let's see differences between mass, weight, gravity, and what happened with the universe. Well, mass is a measurement of the amount of matter that a body has. It is measured in kilograms. Okay, so mass is something related to the amount of matter. Unit, kilograms. It doesn't depend on the place where it is measured. But weight is a force. And the force is, the unit is called newtons. The unit is Newton, N. That is the unit for forces, the symbol N. Okay? So this is a difference with the mass. Mass, unit kilograms, weight, units are newtons. Mass is a number, is amount of matter, but weight is a force. Mass, it is not a vector, it's just a number, but weight is a vector, a force vector. Well, of course, this force of gravitational attraction is acting between planets and stars. For example, our planet, the Earth, is going around the Sun because of this force of gravity. By the way, the force of gravity is always attractive. It is not repulsion. There is no repulsion between bodies. Always is attraction among them. If the bodies rotate fast enough, the force of gravity will prevent them from separating, and they will continue rotating forever. For example, the planets around the Sun. And why is this? Why is this happening? For example, imagine a cannon, and we may fire, and the cannonball is going some distance. For example, over here. If we increase the powder and the velocity is increased the same way, it can go further away. But imagine we increase a lot the velocity. And then what will happen is, instead of going down, like here, it can make like an orbit. It can go in surrounding the Earth. That is what happened with the the International Space Station. The International Space Station, IES, that is surrounding our planet, is orbiting. Our universe is really huge, is very, very, very large. The distances are huge distances, are very large distances. And we cannot use kilometers for that, to measure distances in the universe. Instead, we use light years. We use light years. Okay? This is the unit for distance in our universe. It's a huge number. In kilometers is this, all this. This amount of kilometers means just 1 light year. And what is 1 light year? It's the distance that light travel in 1 year. So light is very, very, very fast. It's moving at this speed, 300,000 kilometers per second. If you do this, light is traveling 300,000 kilometers just in 1 second. So imagine all the seconds in 1 year. If you multiply the velocity, this number, times the seconds in 1 year, what you get is this number, the kilometers in 1 light year. So light year is a unit of distance. It is not a unit of time. It's a way to measure distances in our universe. For example, the closest star to us is called Proxima Centauri, Alpha Centauri. And this is about 4.3 light years from us. And this is the closest. Imagine this number multiplied 4.3 times. It's a huge number because our universe is very, 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 very large. How can we get this number? What is the way to find this number? Well, to do it, we need to do this calculation. We need to do some calculation. That is, multiplying 300,000 kilometers per second times the seconds in 1 year. And how can we get that? Well, in 1 year, as you remember, there are 375 days. And in every day, we get 24 hours. And every hour, in just 1 hour, we get 60 minutes. And in 1 minute, there is 60 seconds. Well, if you multiply all these numbers, the result is this. Try at home with your calculator and you see that you get the same number. So the final result is in kilometers. So 1 light year is calculated like this. And you get this huge, huge number. It's about 10 billion kilometers. And so far, we finished today knowing this. What is 1 light year in kilometers?